Okay, I've got a subtle, I don't want to call it a cheat, but it's something you can take advantage of in 2 dimensions that you really can't do in 3 dimensions. This is a plot of the curve from the problem you're asking about. R equals t for I and cosine t for j, and therefore its r prime would be 1i minus sine t. And so the unit vectors that occur at the t equals pi over 4 mark and the t equals 3 pi over 4 mark right here, the unit tangent vectors would both come from this. And notice in the tangent direction, both of those vectors would be the same. I don't have them drawn on here, but they would both be going toward the bottom right. Okay? And the specific unit tangent vector that you could get at t equals pi over 4 would be this. You found it by plugging in pi over 4 here. So the unit tangent vector at pi over 4 would have these 2 components, and then when you rationalize and do the algebra, you get a root 6 over 3i minus root 3 over 3j. So it will be pointing right and down in the tangent direction from pi over 4. You'd have the same unit tangent vector at 3 pi over 4 also. Now here's the clever little cheat that I was telling you about. Oh, that's Oscar yawning over there, by the way. Hey Oscar, how you doing, buddy? A clever cheat you can do in 2 dimensions that you can't do in 3 is any vector perpendicular to this one would basically cause you to reverse the components like this, and to do a sign combination that would guarantee a dot product of 0. So see, there are two unit normal vectors that you could have for this unit tangent vector. If I did the dot product with this pair, the unit tangent, and this one, notice you'd get a negative root 18 over 9 and a positive root 18 over 9. That's guaranteeing that those are perpendicular because that's a 0 dot product. And you could also do this combination. This is another unit normal vector that you could add to this unique vector here. So this would give you a dot product of positive root 18 over 9 and then minus root 18 over 9. So again, these are 2 vectors that are guaranteed to be perpendicular to this one. And since the specific unit normal vector that you need at pi over 4 would have to be pointing into the curvature, had to be pointing this way, it would have to have a negative I and a negative j component. So that means the unit normal vector that you should have there should have these 2 components. This should be your unit normal vector at the t equals pi over 4 mark. Negative root 3 over 3i minus root 6 over 3j. And then the unit normal vector that you'd have here at the t equals 3 pi over 4 mark would have to be pointing to the upper right. It had to have a positive I and a positive j component. So that means this has to be the unit normal vector at the 3 pi over 4 mark. I also tried to go through both the shortcut calculation as well as the regular, t prime over magnitude t prime calculation to get that normal vector, and both of those are really, let's just say they're kind of cranial kidney stones. But this one works pretty well if you don't mind that subtle rearrangement of the I and the j components to produce a perpendicular vector. It's one sort of kind of clever way to use the geometry to your advantage in this case. And if you don't like this answer, just let me know, and I'll try to work it out the long way so you can get some kind of semblance of justification of those formulas. Take care.